Hi everyone, myself Steffina Morin, Assistant Professor, Department of Computer Science and Engineering, St. Joseph College of Engineering, OMR, Chennai. Today we are going to discuss about the topic that is page replacement algorithm, which is the most important topic in your operating system. First, before going to your page replacement algorithm, first we need to see what is meant by paging. Paging means it is one of the memory management technique that is whenever you need to execute one program, the process is mainly loaded from your secondary memory into your main memory. That is your memory management technique, that is your paging. Paging is basically it's allocating a memory for your process. That is your paging. So here some terms are here. So that is your pages and then your frames. First your frames are means here each and every process is split up into your fixed size blocks. These pages means your processors split up into your fixed size blocks. Fixed size blocks are known as pages, that is P1, P3, P4. These are the pages which is in your logical memory. You need to fix this allocating these pages into your frames that is present in your physical memory. Frames are your memory space, that is your memory is divided into fixed size, that is your frames. So each and every process is split up into your fixed size blocks called pages, and then each and every memory space is divided into a concerned fixed space is known as your frames. That is your F1, F3, etc. up to F5. So here you need to replace. Here it's a paging is a memory management technique. That is, you are going to allocate these and every page. That is your process, allocating these process into your frames. That is your physical memory. First, whenever you need to execute on process, your process has to be loaded from your secondary memory into your main memory. That is your paging concept. In this paging concept, how comes your page replacement algorithm? That is replacing the pages. That is replacing the existing page with a new one. Replacing the existing page with a new one. Whenever the frames are filled. Here for example, here we have six pages. We need to fix the 6 pages into your frame size of 5. So first we have to allocate this P1 into first allocate this P1, that is your page 1 into your frame 1. So frame 1 and your page 1 is your frame 1 consists of your P1, next your P2, P4. We have insert each and every pages into your frames accordingly. So next here you need to last one is your page 6. Now you need to insert the page 6 into your frame. That is, but your frames are filled. So this time you need to replace the existing page with your new one as per some principles. So some techniques are FIFO and then least recently used and then optimal page replacement algorithm and then most recently used. These are the techniques to be followed to replace the existing page with the new one. That is the page replacement concept. Page replacement concept means you need to replace the existing page with a new one as per some of the techniques we have followed. That is your first thing is your FIFO principle and then LRU, optimal and then MRU. FIFO means first in, first out. Least recently used. LRU. And then optimal page replacement algorithm. Finally, most recently used algorithm. We will see one by one in your next. We will see one by one. That is your first in, first out, least recently used, and then optimal MRU. First one is your first in, first out. That is, you need to replace the first element which is going to be inserted in your first thing. That is, P1 is inserted first. So you are going to replace this P1 with the P6. That is your first in, first out principle. As per the first in, first out principle, you need to replace the first page with the new one. That is replacing the existing page with the new one. That is going to be a page replacement algorithm. There are some techniques to be that are algorithms are FIFO, LRU, optimal, and then most recently used. In the FIFO principle, that is first in, first out. You are going to replace the first page which is going to be inserted, which are inserted first. That is going to be replaced with the new one. That is your P6 is within the page of P1. Your P1 is to be removed and then P6 to be filled in your first frame. Next, as for the LRU, least recently used. Which one is least recently used in the future? That going to be least recently used in the previous one. Which one is going to be least recently used in the previous one? That is going to be replaced with the that page going to be replaced as per the least recently used. For this optimal page replacement algorithm, you are going to replace the further page. That is your which is the page which is not to be used in the future. So that is going to be replaced. That is optimal page replacement algorithm. Next one is your most recently used. Here you are going to check again in your previous pages which one is going to be a most recently used page. That is going to be replaced first to as per the page replacement algorithm. So let us see with the each and everything as per the as like a problem. We'll see the problem as for each and everything as for FIFO, LRU, optimal, MRU. We are going to calculate the problem and then find out. We need to find out for each and everything, that is your page fault. After calculating, you need to find out page fault and then page speed. That is your page fault means whether you need to check whether the required element is present in the required element is present in the frame or not. If it is present, that is going to be a page hit. If it is not present, then you are represent as page fault. Next is your hit ratio. Hit ratio formula is equal to, after the finding out each and every problem, you need to calculate page fault, page hit, and then your hit ratio. Your hit ratio formula is number of page hits divided by total number of reference string. Here another term also we need see, that is swapping, that is swap in, swap out. That is here you are going to insert that P1, P6 here, P6 you are inserting P6 into the frame. That is your swap in. That is P6 is swap into the page. P1 is swap out of your frame. That is your swapping principle. So swapping is swapping of the P6. P6 to be inserted in your frame 1, that is swapping. Swapping is replacing the page, that is swapping. P6 to be replacing your P1. So existing P1 has to be swap out and then inserting your new element to be inserted in your P6 to be inserted here. So that is your swapping process. So now we are going to see about see this page replacement algorithm with the problems. Now we see about first in, first out. That is here you are going to replace the first page with your new page. This is your reference string, that is 132, 423, 142, 413. These are the reference string. You are going to insert these reference strings in your frame size with the frame size of 3. That is your question. Now I am going to draw out your reference string. First you are going to enter your strings, that is 1, 3, 2, 4, 2, 3, 1, 4, 2, 4, 1, 3. Now your frame size is 3, that is F1, F2, F3. Initially your frame is to be empty, that is each and every frame is empty. Now only you are going to insert this each and every page in your page string in your frame. First one is you are going to insert your 1 in your frame. So insert 1 in your first frame. This is to be your page fault. Why? Why I am fixing is a page fault means whenever your memory space. First whenever you are going to enter one page into your main memory, first you need to check whether it is present in your main memory or not, or else your frame. If it is present in your main memory, that is your hit. If it is not present in your main memory, that is your page fault. Now one is not present in your frame, so you are fixed as page frame. Now we are going to insert 3. So 1, you have already inserted 1, that is the 1. Next in your frame 2, you are going to insert this 3. So 3 is also not present in that frame already. So that is also your page fault. Now we are going to insert 2 in this frame, that is 1, 3. You have already inserted in this frame 1, 3. Then you are going to insert 2 in your frame 3. It is also your page fault, that is because 2 is not already present in your main memory. Now only we have inserted 2 in your memory. So that is your page fault. Now next you are going to insert 4. So in 4, search for this. Search whether your required page 4 is already present in your frame or not. That is 1, 3, 2. There is no 4. So you are going to insert this 4 in your frame. So 4 in your frame means first. In this you are going to use this technique, that is first in first out. That is you are going to replace the first page which is inserted. That is first you insert panipo, that is your 1. So you are going to replace this 1 with 4. 4, 3 and then 2. So this is your again page 1 because 4 is already not present in that. Next you are going to insert 2. Search for 2, whether 2 is present already. So 4, 3 and then 2. That is going to be a page hit because 2 is already present in your main memory. So it is called page hit. Next you are going to insert 3 in your main frame. Check whether the 3 is present in your main memory or not. 4, 3, 2. 3 is already present. So this is also a hit. 4, 3 and then 2. Now you are going to insert 1. Check whether 1 is already present in your main memory or not. 1 is not present here. So you are going to replace the first page with your new page. So 1. Which one is going for the first one? You have 3 is already present. 3 is here. So you are going to replace 3 with the new one. That is 4, 1, 2. So here also we replaced as page fault. Then you are going to insert 4. Check whether 4 is present in your main frame or not. Here is already present. So that is also a hit. Now we are going to insert 2. Check whether 2 is present in the present frame or not. That is already present here. So that is also a hit. So 4, 1 and then 2. Again you are going to insert 4. 4 is already present here. So that is also a hit. Now we are going to insert 1. 1 is also present here. So that is also a hit. Next you are going to insert 3. Search for the page which is going to be replaced. That is you are going to replace the first page. That is your principle as per the technique, that is before principle. First in, first out. Whichever is inserted first based upon these 3. 4, 1, 2. So which are going to insert this? Inserted first in this, 2. 2 only is your first page among these three. That is 4, 1, 2. Among these three, we have inserted 2 only first. So we have replaced 2. So 4, 1, 3. This is also a page fault. This is your first in, first out technique. Now we are going to calculate number of page faults. Number of page faults. Count the number of page faults, that is PF. 1, 2, 3, 4 and then 5 and then 6. Next, number of hits. Count the number of hits, that is 1, 2, 3, 4, 5 and then 6. Now we are going to calculate the hit ratio. That is number of page hits divided by total number of reference strings. That is, your hit ratio is equal to number of pages divided by total number of reference strings. That is equal to number of pages is strings. You are going to count the total number of reference strings. Here this is our reference string, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 bar 12, that is equal to 1 by 2, that is 0.5. Hit ratio is 50%. 50% for your first in, first out. In your first in, first out, you are going to replace the existing page. Which one is you are going to existing page means whichever you are inserted the first in your main frame. Which is your first page in your main frame, that only you are going to replace with your first in, first out. Next, you are going to see about LRU, that is least recently used. The second technique is LRU, that is least recently used. Here also, if your frame size, whenever you are going to execute one program or else your process has to be loaded from your secondary memory to your main memory. If the process has to be, if your blocks are filled up, then you are going to replace the existing page with your new page. For that, we are going to see about least recently used. Here, you have to replace the existing page with, when you have to see whether which page is least recently used in the among the pages. So here same thing, that is you have to write the reference string again 1, 3, 2, 4, 2, 3, 1, 4 and then 2, 4, 1, 3. Here again your frame size is 3, F1, F2 and then F3. In the same thing, here also first your frames are empty. There is no data in your memory space. So now we are going to insert each and every page into your frame. So first frame is 1. You are going to insert 1 in your frame. Whether you have to check whether the required string is present in your frame or not, or is your main memory. So 1 is not present in the main memory, hence it is your page fault. Next you again check with 3. So 3 is also not present. So 1, 3. So that is your page fault. Then you are going to insert 2 in your frame. Check whether 2 is present already. So there is no. So 1, 3, 2. Now you check whether you need to insert 4. 4 is your record page. Whether it present, whether you need to check whether it is present in your frame or not. 1, 3, 2. There is no 4. Here you need to check whether, put one arrow like this. That is your required string. Which required string? In this you have to do the left arrow. That is least recently used. Which string is least recently used in this among these three? Is 1, 3 and then 2. Which one is least recently used among this? For you have to replace 4 with that least recently used page. Among this, 1 is least recently used. 1 is here, 3 and then 2. Which one is least recently used? Among this 4. So in 1, this is going to be in the here. So 3 is here and then 2. So this is 2 is most recently used and then 3. This is second most recently used. 1 is least recently used here. So you have to replace 1, 4, 3 and then 2. You are going to move this left hand side arrow. In least recently used, you are going to move that. Which string is you need to insert from that string. You are going to check whether the which one is least recently used according to your left side arrow. That is 4 means in this frame 1, 3, 2. In 1 is 2 is most recently used here. So here you need to follow. And then 3 second most recently used. And then your 1 is only least recently used. That is it's going to be your last one. So you are going to replace 1 with 4. Now we are going to here also these are the page fault. Now check whether 2 is present in your frame or not. 2 is present. So 4, 3, 2. That is going to be your hit. Then 3 is present. Check whether 3 is present or not. 4, 3, 2. So then you need to check whether 1 is, you need to replace 1. Check whether 1 is present in your page or there is no 1. So you need to replace 1 with this, any of the 1. So again you are going to replace, check with left hand side. So you need to replace 1. So here your 4. 4 is recently used. So in your 1, you need to replace 1 means you need to check from these 3. So 3 is most recently used among this. And then 2 is also most recently used. That is second most recently used. Then you are going to replace 4. That is your least recently used. So check with, if you need to replace this one means you are going to replace, you are going to check whether the left hand side arrow, that is your left side elements. Whenever you are going to replace this one, you are going to check the left hand side elements. So first this 3 is recently used, most recently used here. Then 2 is also second most recently used. Here 4 is least recently used. So you are going to replace this 4. So 1, 3 and then 2. So this is your page fault. Now we are going to replace 4. So now check whether 4 is present in your main frame or not. No. Here 1, 3, 2. So you need to check whether same thing 4 in this left side 3 arrows. That is 1 is most recently used and then 3 is also second most recently used and then 2 is least recently used in this. So you are going to replace 2 in this. So 1, 3 and then your 4. Okay. Then you are going to insert 2. 2 is, so now you are going to check whether 2 is present in your main memory or not. There is no 2 is present here. So again you are going to insert 2. So next again you are going to check to insert 2. Again you are check with left hand side elements after the 2, before the 2. That is 4 is most recently used and then 1 is second most recently used and then 3 is least recently used. That is 3. So you are going to replace 3. 3 with 2. 1, 2, 4. This is your page fault. Then you are going to reinsert 4. 4 is, check whether 4 is present in this memory or not. 4 is present here. So that is according to your heat. And then 1, check next one, the next element in your reference string is 1. That is, check whether 1 is present in your string or not. That is 1, 2 and then 4. So 1 is present here. So 1, 2 and then 4. That is also a heat. Now we are going to replace 3. 3 among 3. Same thing, you are going to insert left hand side arrow to check whether 1 is most recently used with the 3 and then 4 is second most recently used, and then you are going to replace 2. That is your least recently used. That is going to replace 2 with 3. So 1, 3 and then 4. That is also your page fault. Least recently used means you are going to, whenever you are going to replace one page, you are going to check. You need to check whether that the previous elements, check with the previous element. Which element you are going to insert? Whether you need to insert this one is your new page. You are going to insert the 3 in your previous page means we are going to replace these new element with the previous elements. Means first we need to check the previous elements. That is least recently. First one is your most recently used. Second one is your second most recently used. Third one is your least recently used. That one is going to be your, you are going to replace that least recently used only while you are going to replace some page in your as per the least recently used algorithm. That is least recently used principle. So now you are going to same thing, number of page faults. Calculate the number of page faults. 1, 2, 2, 3, 4, 5, 6, 7 and then 8. Number of page fault 8. Number of page widths 1, 2, 3, 4. So number of pages is 4 divided by total number of reference frame 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 bar 12, that is your least recently used. Now we are going to see about optimal page replacement algorithm. That is about optimal page replacement algorithm. Same strings. So your frame size is 3. So now you are going to insert your pages into your frame as per the optimal page replacement algorithm. What is the optimal page replacement algorithm is? That is, you are going to replace the page which is not going to be used in your future. In least recently used, you are going to replace. You are going to use this left side arrow. That is, you are going to reference your. You are going to check whether this elements which is one is least recently used in your previous thing. But here in your optimal page, you are going to use this arrow. That is, which one is going to be used in your, which one is not going to be used in your future. So now, same thing. Now we are going to, initially your frames are empty. Suppose we need to insert 1 in your page thing. That is your page fault. Now we are going to insert 3. That is 1, 3. That is also your page fault. Because the 3 is not present in your frame, that is going to be a page fault. So next you are going to insert 2. That is 1, 3, 2. That is also your page fault. Now we are going to insert 4. So check whether 4 is present in your main memory. No. And also your frames are filled. There is no empty space available in your main frame to insert these 4 in your thing. So now you are going to replace this existing with the new one. So now you are going to check with this arrow. We are going to insert this 4 means you are going to check the next 3 elements. Which one is not used in your future? That is least recently used in the future. That is, you are going to replace the least recently used in the future. Replace the page which is least recently used in the future. That is, now you have to check 2. 2 is already present, but this is least recent. Next used in your future. Next 3 also. 3 is also present. 1 is only going to be your least recently used in the future. Now you are going to replace 1. So 4, 3 and then 2. You replaced, that is going to be a page fault. Now we have checked whether 2 is present in your frame or not. So 4, 3 and then 2. 2 is already present, so that is your page hit. Now we are going to check 3 is present here or not. So 4, 3, 2. 3 is already present here, so that is also your hit. Now you have to check for 1. So for this one, you need to check whether 1 is present here or not. 4, 3, 2 only present. So you need to check whether next 3 elements. Check with next 3 elements. That is whether 4 is already present. That is next used element. Next your 2 is also. So 4 again. So here you have used 2 4 times it's here. So you are going to check. Replace 2 here. So you need to replace 4, 3 and then 1. 1 is least recently used. So next you are going to check whether 4 is present here or not. 4 is present here. So that is 4, 3, 1. Here it is one page fault and here already present. 4 is present here. So that is your hitch. Now you are going to check whether 2 is. You need to insert the required pages 2 in your page string. In your reference string, you need to insert 2 is your required page. So you need to replace 4, 3, 1. So check whether next 3 elements. So next 3 elements means 4 is next used element and then your 1 is an again used element. 3 is going to be recently used in your future. That is 3. So you are going to replace 3 now. So 4, 2 and then 1. Here also that is going to be a page fault. Now you have to check whether 4 is present in your memory. So 4, 2, 1, that is your hitch. And then next 1 is check whether 1 is, you are going to need to insert this 1 in your string. So 1, so check whether 1 is present or not. That is present. So 4, 2, 1, that is your hitch. Because 1 is present here. Now we are going to replace 3. 3 is the last element. As per the optimal page replacement algorithm, if you need to replace anything in replace the page, you need to check whether with the next element, whether the elements which is least recently used in the future. So here it is going to be a last one. So now you are going to check which one is. Here we are using the FIFO principle for the last one. As per the optimal page replacement algorithm, whenever you need to replace the page with the existing one, we need to check which element you need to replace means that element which is going to be least recently in the future. But here it is the last element. You cannot able to check the next element. So here you are using a first in first out principle to replace the page. So first in first out means which one is the first inserted page, that is your. As per the 4, 2, 1 means 2 is inserted here, 1 is inserted here. Your 4 only inserted from here. So you need to replace your 4. So 3, 2, 1. This is also your page fault. Now this is your optimal page replacement algorithm. For this also you need to calculate number of page faults, number of pages and then total number of hit ratio. Number of page faults is calculate 1, 2, 3, 4. 5, 6 and then 7. That is number of page fault. And then number of page hits means 1, 2, 3, 4 and then 5. hit ratio, that is number of pages is 5. Total number of referencing we already seen 2, 6, 9, 12. 5 bar 12. That is your percentage. 5 bar 12 hit ratio is 5 bar 12. That is your optimal page replacement algorithm. Next we need to see about most recently used.